Hello, and today a different video. I'm going to make a little power supply, linear one, and there is the schematic. Hope you can see it. Oh, it's not upside down or something. If someone wants it, I can make a photo and post it. It's a relatively easy circuit. It just uses a standard L7805 voltage regulator, 5 volts in this case, and a little mains transformer. It's probably mirrored, isn't it? I'm sorry. I don't know how to change that. Well, the components are relatively easy. We have a transformer, fuse for the primary, bridge rectifier, snorting capacitor, some decoupling capacitors, and the L7805 regulator. Diodes are 1N407, pretty typical. Actually, I don't know where I put my, or I couldn't find my, so I use UF407, same thing, but for high frequency in this case it doesn't matter. Capacitor, about 2200, again didn't find one, so just two 1000 micro parallel. Ceramics will be 0.1 micro, 100 nano. That's basically it, and let's go to the circuit board then. Hope you can hear me. I already mill out the safety for the high voltage to primary. I spare you from that. That's just like using a, what you call it, like a small grinder and moving it. I guess you could attach it. And I'm going to use for the connection to the, going to use this Vagos Sondrons, and this is the regulator. I think I showed that already. Oh, dropped it, of course. I already put in the transformer, and we can put the Vago in. For the fuse holder, I will have to desolder it from these old Microvive inrush limiting filtering board. And yeah, we will of course use a smaller fuse, not this, I think that's 8 or 10 amp. We're going to use a much smaller one. We're going to need soldering iron, solder of course, flux maybe. Maybe some degreaser to clean the board. Probably not the right stuff, some of that. Small side cutters, needle nose, small screwdriver. I don't think we need a marker, but tweezers. And I think we should start by just soldering in the, start soldering the Vago, I guess. I made it so it fits really nicely. What you can do is, it doesn't fall out, you can slightly bend those, in the needle nose, slightly bend those Vago terminals, just a little bit, so they don't fall out. I think that should be enough. Yeah, it's plenty. So it's gonna go anywhere. And you take your solder and just start soldering things in. I hope you can see it. Let's start to solder. I just put a little bit solder here and here so it doesn't fall out. So now you have to connect these, of course. So if you're going to use this, a small piece of thin copper wire, I will strip this. I try at least. I hate this service. Okay, there we go. Let's now try to pull the plastic away since we don't need that anymore. Yes, there we go. And oh, you cannot see, like it's now stripped. Straighten it, nice and straight. And what you now can do is basically bend this such a way that it creates, in this case, like a 90. Straight, nice and straight. I'm gonna cut it roughly here. I like how those pliers don't drop the wire. They have like a little spring thing here. Nice. Now we position that wire. Yeah, maybe a little bit of straightening and trimming. And now we try to solder it without it flying into, well, on the surface of the moon. Hopefully it doesn't land there, right? I'm gonna try something, I hope it works. That's my method. Maybe you have a better one. Of course it turned. Come on. It's okay. I'll fix this. Yeah, I can see it anyway. I have to like, straighten it a little bit. Whatever, this video will be unedited, so whatever happens, it just will be in the video. No, it doesn't need to be all perfect. It will work anyway. Trying to like straighten it a little bit and put it into shape and everything. Maybe cutting a little bit, it's a bit long. And now we can like solder it all the way. This will be a long video. Well, if you want to skip, feel free to skip parts if you just not in a mood to watch the entire video of me doing this. Or maybe you just feel bored and enjoy electronics like me and you want to watch me. In that case, feel free to do that. Nice. Usually I don't talk so much, but I will just talk in this video. Hopefully you can see this. Oh, sorry if not. Yeah, you can. There we go. Sorry if it's not in focus or showing it wrong. It's already 8 minutes. This is going to be a long one. Now don't mix up the tin and the wire. That one's not gonna melt. Try to solder. What we could do next is, I guess we could try to get the fuse out. Yeah, let's get the fuse out. This is going to be difficult. I could get my desoldering pump, but I'm not in a mood to get it. Let's try this. Probably the wrong way to doing it. Maybe it doesn't work. It works. It worked. That is our price. But I want the other one also, so let's do this next. Let's actually add a little bit of skin. That part better. I probably look like I'm a noob, isn't it? I know I'm doing this for many years, but whatever. Okay, let's me see if this is... Okay. It's not that hot. Oh, this one is different in the other one. One is thinner, one is thicker. Can you see this? Maybe. Oh, maybe I need to drill. I think this is work like this. Yes, I'm going to need to drill this. Didn't think this is will be like that. I think. I guess I need to get the drill and the drill bit. Put my microphone on the table. Just wait. I'm back. Drill. That's about the right drill bit. Do you see how do I want it? Put this one. The far away hole needs to be drilled out. Okay. Okay. Nice and slow. Nice and slow drilling and works. Now it should fit into the hole. Hopefully. Maybe. Oh yeah, that's a nice and snug fit. Nice and snug fit, like it. Same for the other hole. Yes. Going to actually bend the legs over of the holder so they don't move. This doesn't matter because you will never have to replace the fuse holder. At least I never think you should need to replace it. Don't know what you need to do to break that one. You should just bend the legs and like crimp it to the board so it's nice and stable. Using the needle nose. It's like crimp now, that's not gonna go anywhere. I will solder it and it's on the board forever. Because like it doesn't matter if it's crimp because you'll never replace the fuse holder, only the fuse, and since you're pulling on it and it's a mechanical stress, I'd rather have it never come out. Take a piece of wire and let me see. I'm going to just put a straight piece in, I think. Yeah, that will work. And drop it. Okay. That's gonna be difficult to solder. Let me tell you that. fix it a little bit. Oh, that's going to be such a long video. It will have probably 0 views. Come on, solder, do your thing. Not the dirt there. Yeah, see, like that. Now the other side, and then the primary side is completed. And Ctrl L in here. Oh, that's a bit much. Bit too much. Okay. Okay. Oh, this is going to be beautiful. I think I want to solder this a little bit down before I cut it. Maybe if I can. Let's hope for the rest. Oh, perfect. People always ask that when you're soldering, you're holding like the wire stuff and it's very hot. How can you hold it? The secret is your fingers are made of asbestos. No, I'm just kidding. You still feel the heat of it. Just don't burn yourself. Oh, I should say this circuit includes dangerous mains voltage, so do it on your own risk. I'm not responsible if you kill yourself. Be careful, and if you don't know what you're doing, just don't do it. Now you can cut the axis of the transformer leads. See, the pliers make it doesn't fly across the room. Nice. That's primary side completed. And now we can get to the fun part, the secondary, that has much more components, of course. On this particular transformer, only the inner ones are connected, the outer ones I think only for stability. They are, if I remember, not connected internally, but you can just solder them both to have more strength. Because the transformer is heavy. It has iron in it, it has steel in it, so I think so good. Yeah, that looks all good to solder too. Maybe I want to solder here a little bit more. Yeah, nice and big solder blob. We're going to get a fuse later, so we don't need it right now. Like this, but smaller. This is like too much current. Now we're going to make the full bridge rectifier. You think the layout, what would be the best layout? I doing this just like in my head. Like layout for the board. Probably like this. I'm going to actually get a tool for bending those legs. Just wait. I am back. Okay, back. This is nice, so you can bend it nice and straight, like perfect, so it fits the hole. And let me bend those diodes. Like these. Nice. Let's do this to all 4, I guess. There's a 5th diode that will be later used. This is across the regulator. Let me see, how can I do this? Maybe. Let me put the diodes in. Important here, watch the polarity of the diodes to make a full bridge rectifier and not, I don't know what you would make if you put it undersized, since short circuit, I guess. No, it's not where I want to put everything, maybe here. No, home to this side. Yes, like that. You can see 2 pointing this way, 2 pointing this way. So later when you connect them all together, they will create a bridge rectifier. You can see that on the schematic. I'll show that already. Let's now see what we're going to do here. Guess we can put this one here, then that one there. Yeah, it's gonna be nice. Going to just bend this one here, yes. This one I'm going to go there and up, I guess. Yeah. I'm going to put this one there and up. Sorry if you cannot see anything. I'm sorry. But I have to focus here a little bit so I don't F it up. Oh, come on, perfect. This is like one side, and then we're going to just, yes, I'm going to bend the transformer pins. Whoa, they are stiff. Because I doubt we will ever need to replace the transformer. Those like 50 Hz transformers are just eternal. I don't know what you need to do to destroy one. So we're going to just blend this one also. So we're going to just solder them together, make them nice and strong. Yes. Now for the other side, I need to go up and to there. I'm going to go this way, and I'm going to go this way. Yes. I'm sorry if there is any voices in the background. Just ignore it. You just can never have silence. Yeah, let Let me see, this is here, so this needs to go this way and just this way. I'll be sure to not make a short circuit. I'm going to need a little bit of my wire again later, but I think we want to solder some of it now, so there is less of a mess on the board. I hope I connected it right. We will know. Okay, yes, this is going to work. Hopefully. Just scream if I make a mistake. Just scream at me. I'm going to need my wire. I'm going to put the wire here, I think. Can I solder it like this? Probably not. Maybe? Nah, it's gonna hold until I connect it more better. I'm going to cut it right here. Don't think I want to bend this side, I'll just cut this side. This is already pretty nice aligned. Now don't heat the diodes or semiconductors in general too long up. Resistors you can heat forever, they will probably not be damaged, but semiconductors are sensitive, so don't solder them for too long. In this case I'm away from the actual semiconductor. I'm just soldering the leads of the transformer, but still I want to use reasonable amounts of time. Don't heat it forever or you're going to destroy the components. If you start to delaminate your circuit board, you're probably heating it up way too much and way too long. You want to use a nice and powerful iron, so you don't need to heat it up forever. It's just quick and hot. It's very quickly hot and melts and everything is good. Let's remove the current flux there. Let's make sure there is no short here. And there is no short here. It's not too hot. Now we are going to need to put the capacitors in. Very nice. Is it Nippon Chemical method? I guess you recognize that brand. And for the ceramics, I have some Chemo Electric, something like that. We are going to continue adding the components to the secondary of the transformer, the regulator and capacitors. Now let me think of the best layout for these, and I'm going to unpack my regulator. It's not very sensitive to electrostatic discharge, but stable as metal grounded, so touching it it should be okay. Mouse things are usually fine. guess if you really discharge static, you destroy it, but usually they are good. The pinout is for those type of regulators: input, ground, output. From the left to the right. Hopefully it makes sense. There's additional diode. Let's see the best layout. I have to think of the best layout. I think I want to put the capacitors in now. Okay. Maybe like this, yes. This looks good, I think. Let me think. Let's bend those leads a little bit out so they don't fall out on me. I used those in a previous project, so the leads are shorter than they usually are. Hopefully they won't fall out. I guess you're not going to. Let me just cut them all the same length, and I'm going to bend them completely over so they don't move. Sorry if you can't see. Come on. Well, that's a bit shorter than I like, but I guess it's going to have to work. Now it's going to fall out, I think. Guess I want to solder them in now. Actually, I want to put a piece of wire, and should I just solder them now, or should I? What? I'm going to bend the diodes first. Now be careful, electrolytic capacitors are polarized, so you don't want to put them the wrong way or they will explode. Or they will explode with the intensity of 1,000 atomic bombs. I'm just kidding. But they have a really horrible smell if they explode, so. What I'm about to do here. I'm going to cut this a little bit shorter. I'm going to bend this like that and like this. I'm going to start soldering things. Yeah, come on. Nice. I'm going to use the cutoff legs of the diodes for a bridge here. I think this is just going to be perfect. Nothing bad, and saving and reusing things if you can. I do have copper wire, but this is copper wire too, and why should I throw it away? Ooh. Maybe I need another one. Edmond decided to go to the moon. I don't know where to enter it. Ne treba sad. Da. I found it, guys. Sorry for the interruption. We found it. Oh, okay. Just that one a little bit. Because I really like that one. Sorry for the interruption. Come on. Okay. Need to put something under here so they're nice and tight. Yes. This is just perfect. Everyone is silent, but when you want to make a video, everyone has to talk. I'm sorry. I am sorry. Come on, you cable. You can see what I'm doing. How do I do this the best way? Yes, like this. I'm going to move the other capacitor. I'm going to solder this one also. For it and then later, or just solder everything together nicely. Like this. Just make this nice and consistent, nice and thick soldering joints, so it lasts forever. Nothing better than when the circuit that you make outlives you, right? Then you know you must make a good work. I'm so sorry about the background noises. Alright. Now we have put in the electrolytics. Small one to the... would be the next thing to put in, I guess, the regulator. And it's filled two ceramic capacitors. How do you want to go in? Let me see. This is the input. It's like this maybe. Input to screw it around. Now those capacitors are going to be a bit annoying. They are so small, they don't want to really go in, they want to fall out, of course. So Sorry if I just fumbling around with the... Sorry if I fumble around with it. Ceramics aren't polarized, so just put them any old way in. Maybe one hole to the left. And this one here, it's the main part. Just put them any old way in. The ceramics don't matter, be careful with the electrolytics, they have a polarity, and careful with the regulator. Hope you can hear me. Okay, so this wants to go that way and then around. I think this is going to work. I'm going to bend this one here. Going to bend this one here. I'm going to bend this one probably to the other side. This one, yes. And this one is going to be bended this way. This one, this is the output. I'm going to bend it this way. This is going to go through the output, so like that. Now let me solder this together. So use having a little piece of the leftover wire. And just solder everything nicely together. Yes. Hope you can see at least something that I do. For the ground, I want to bend it, I guess. I want to bend it this way. Sorry, you cannot see what I'm doing, but I have to focus myself to not make a mistake. Going to need again wire. Come on, come on. I know you want to be here. Yep, that one is hot. I'm going to bend it something like here. Yes. Nice. Nice. There will be a lot of fumbling around with these to make it perfect. This is going to be the output terminal, I guess. Yes. Let's see where do I want to put the output terminal. Maybe closer. I guess this will work. Maybe... No, maybe I want to put it the other way around actually. I guess I want to put it a bit closer. Yeah. I think this is a good way. Let me just fumble with the wire until it's just perfect. Just solder this a little bit so it doesn't want to fall out. It's perfect. We can just solder the ground. I think it's complete at the ground. And this is the capacitor. Yes. Just be sure, make sure to not make a soldering bridge where you don't want one. It can be difficult to unsolder them once you make them. Make sure to nicely solder, nice thick soldering traces so everything has a good connection. I'd rather use a little bit too much solder than not enough. This looks good. Maybe a little touch up here. Well, it will be a 1 hour video, I guess, so a little bit more. Okay, don't make a bridge, perfect. The last thing to connect is probably the diode. I have to put the diode in. Don't forget the diode. That was, let me see here, and can go right there. Okay, I can put this one in either now or later. Let me actually put it right now in. Be sure to put it the right way around him. Where could I put you? Where could I put you? Because right spots right there. I want to go. I think. Oh, actually, I think I want to go over. To go in. I know you want to go in. I'm going to bend you like this and like this, yes. Maybe you can see what I'm doing, maybe not. This one will probably be just perfect for this. Oh, no, don't go away. I need you. Oh, that's gonna be a nice dream to solder. It's going to be a dream. Now that I solder it a little bit, I can actually bend it. Come on. Yes. Now we can just finish the soldering. Turn it. Can use plenty of solder. You want a nice and good connection. We don't want a bad connection there. And we're going to solder the last diode lithium. It's nice and thick. This looks good. This one looks not so good, I think. Sorry if you can't hear everything that I'm saying. I'm talking a little bit with myself. Okay, clean the tip here. This one. I think that's done. Oh, come on back. Check if there's anywhere a bridge. No. I don't see any bridges. And that's the completed soldering. This side. So good. Does it work? We will find out soon. Maybe I want to use a little bit of that eraser to clean some of the sticky flux stuff. Of course. If there's any like spilling or something of the flux, should remove it. Not that it would be conductive or corrosive or anything, so it doesn't really matter. Just clean the stickiness away. Meh, still a little bit sticky, who cares? Should at least work. Just check if there's any like suspicion places. Just check them before you turn on. You don't want to turn on when there's a short and blow up the IC or power supply, basically. It's all good to me now. Input, output. Pretty good. Guess I'm going to search for a fuse and we should turn it on. See what happens. Will it blow up? Will it work? We don't know. I'm just gonna get a fuse. I'm back. Found a small glass fuse. It is 100 milliamps low blow. Calculated is 25 watt. That's probably too much for a small transformer, but I must have this one at hand. Maybe I put a smaller one in later. Let's put it in. Nice. Better some fuse than no fuse, I guess. So I guess it would still blow it if there is a short. We can add output fuse on the wire if we need. I think those 78 are internally short circuit protected, but I'm not sure. Was it over temperature or something like that? So low to me, polarity looks right, C looks good, capacitors look all soldered in good. Yes, we can turn off the soldering iron. Okay. Oh, if someone is interested, I use a ERSA, made in Germany, 40 watt. Works fantastically for many years, no problem with that one. Going to need to get some wire, and we should try to turn it on, I guess. Now let me find some wires. I will be back. I guess I have to pause. I have to search for pieces of wire. I will be back in a second for you, and we will see. Hello, back. For me it was a few minutes, for you was just a second. I get the wires, stripped them and prepared. I get the multimeter and we prepared the mains and the output wires, and this is not properly connected, don't touch anything, electric shock, the table is non-conductive, so it should be okay. And we don't want to lay down that like on, because there could be a piece of wire under it and create a short circuit or something, so. But for now, this should be okay for a test. I'm going to use my power supply and raise the voltage slowly. We already having 5 volts there. 5.055 volts, and it's doing exactly what it needs to do. Be careful when you try touching something that's energized. The DC link voltage is 8.7 volts, expected from a 6 volts transformer, and the output is 5 volts, so it's regulating. I now should connect some load and see if we still have good regulation, but for these I need to get a load resistor or something, and I think I will also set up the oscilloscope. So again, just wait a little bit and I will be back for you. It's just a second. I'm back again. Set up test jig. So we still have 5.54 volts. be drawing almost 200 milliamperes. We have 225 on the Variac, 220 some, it's fluctuating a little bit. And the wave on the oscilloscope looks just perfectly smooth. I wish I could show it to you, but I mounted the camera, so you have to believe me. Well, that's it, it's working. This was intended as a small power supply, not supplying more than 200 milliamperes. I used the overrated transformer, but I was have this one. Really, you could use a much lower power transformer, so I think 10 VA. 5 VA would be probably plenty. They also have this one, so whatever, I use that one. And the regulator has no heat sinks, so you should not really pushing it because it's gonna get hot. Yeah, that's just intended for like low power logic type things that needs very smooth DC, like switch modes, so 100, 150, maybe 200 milliamperes top, so this is more than enough. Components are very overrated, they will last forever, basically. I mean, nothing is forever, but you know what I mean. It was just a little fun project. I also have some time, so yeah. Thanks for watching, and if anyone still is watching, you're a legend, because it's over 1 hour of me talking and soldering. And yeah, if you're still watching, make a comment. You have to be a legend. Yeah, thanks for watching. Bye. See you soon again. I end it like this now. Enough of talking. Bye.